All right. So hello.
Good morning, sir.
Good morning. So we are having class now after Saturday. I mean, today is Wednesday. So after probably 4 days, isn't that it?
Yes, sir.
Okay. So regarding FIR filter, have you read FIR filter? Any doubt if you have any FIR filter? No doubt, I think.
স্যার
হ্যাঁ।
আগের দিন যেটা আপনি বলেছিলেন না ব্যান্ড স্টপ ফিল্টারে যে এক্সাম্পলটা দিয়েছিলেন অ্যাসাইনমেন্টে ওইটা করে দেখতে, তো ওইটা পয়েন্টস গুলো এলোমেলো আসছে তো।
না, ওটা অনুষ্কা সলভ করেছে তো। অনুষ্কা সলভ করেছে, সলিউশনটা অনুষ্কাকে বলে দিচ্ছি, আমি তোমাদের দিয়ে দেবে। অনুষ্কা সলভ করেছে।
তো ওটা গ্রাফটা ঠিকঠাক আসছে?
একদম একদম পারফেক্ট এস। আমি দেখে নিয়েছি অনুষ্কা সলিউশন করেছে। অনুষ্কা আজকে আসেনি ক্লাসে? এসছে অনুষ্কা? হ্যাঁ আছে। এই অনুষ্কা ওই সলিউশনটা পাঠিয়ে দেবে তো কেয়াকে, ঠিক আছে? কেয়াকে পাঠিয়ে দেবে, আর যাদের লাগবে তাদেরকে সবাইকে দিয়ে দেবে, ঠিক আছে? ওইটা ঠিক আছে, তোমারটা আমি দেখে নিয়েছি, বুঝলে? তাহলে ওইটা পেয়ে যাবে। আর আরো কিছু আমি প্রবলেম দেবো, সেগুলো করতে হবে। যাই হোক, নেক্সট উইল টু স্টার্ট আয়ার ফিল্টার। হ্যাঁ বলো,
কিটা বলেন? কোন সলভিং প্রবলেমটা?
ওই যে অনুষ্কা যেটা সলভ করেছে, তোমরাও করেছো তো?
কোনটা করেছে? ওই 0.3 0.5 এরটা
ব্যান্ড স্টপ ফিল্টার, ব্যান্ড স্টপ ফিল্টার।
হ্যাঁ, লাস্ট দিন যেটা দিয়েছিল এসেছে।
হ্যাঁ এসছে। ওইটা আমার অমিত ক্যালকুলেশন করেছে। অমিতরও একই রকম এসছে না ক্যালকুলেশন? হ্যাঁ অমিত করেছে, তাহলে সব ঠিক আছে। দুজনে যখন ঠিক আছে তাহলে ঠিক আছে। তাহলে আরেকজন কে করেছে? আকাশ করেছিল বোধহয়। আকাশও করেছিল। আকাশেরটাও সলিউশন আমি দেখেছি, ঠিকই আছে, ঠিক আছে। তো যারা ওইটা নিয়ে নেবে, ওটা থেকে দেখে নেবে, একদম ঠিক আছে। আমি প্রবলেমটা চেক করে নিয়েছি, ঠিক আছে, তো অসুবিধা নেই, ওটা করো, ঠিক আছে। আর
স্যার লাস্ট দিনে কুইজ দেননি না?
না, লাস্ট দিনে কুইজ দিইনি। কুইজ এখন সব দিন দেবো না, কুইজ এখন সপ্তাহে 2 দিন দেবো, ঠিক আছে। আর নোটস হচ্ছে আমি বুধবারে যেটা দেবো সেটা ওই 4 দিনের নোট, ঠিক আছে। ওই 4 দিনের নোট মানে ওই একসঙ্গে পেয়ে যাবে তোমরা। মানে আজকে আমি নোট পাঠাচ্ছি মানে গতকালকেরটা, আজকেরটা, কালকেরটা আর শনিবারেরটা, 4 দিনের নোটটাই তোমরা একসঙ্গে পেয়ে যাবে, ঠিক আছে। তো আমি 4 দিনের নোট পাঠিয়ে দেবো, আর 4 দিনেরই কুইজটা দেবো আমি শনিবার। সপ্তাহে একদিন কুইজ দেবো। ওই 4 দিনের কুইজই শনিবারে দেবো। 10টা কোশ্চেন দিয়ে দিলাম বা 8টা কোশ্চেন দিয়ে দিলাম, সেরকম দিয়ে দেবো। রোজ রোজ কুইজ দেবো না, আর রোজ রোজ গুগল ফর্ম বানানো সময় লাগছে। আর দ্বিতীয় কথা হচ্ছে যে তোমার এখন 4 দিনের নোট একসঙ্গে দিয়ে দেবো বুধবারের দিন। বুধবারে আর শনিবারে ক্লাস হবে, ওই 10টা থেকে 10টা 40-এর মধ্যে ক্লাস হবে, 2 দিন ক্লাস হবে। এবং ক্লাস যতদিন তোমাদের কলেজ না আসছো ততদিন ক্লাস চলবে, তো সপ্তাহে 2টো করে। তারপরে যদি মনে হয় যে আরো কমাতে হবে, তাহলে সপ্তাহে একটা ক্লাস করে দেবো। শুধু বুধবারের ক্লাসটা হবে আর শনিবারের ক্লাসটা বন্ধ করে দেবো। আপাতত চলুক, যতদিন আয়ার ফিল্টার শেষ না হচ্ছে। আয়ার ফিল্টার শেষ হয়ে গেলে সপ্তাহে ক্লাস একদিন হবে, কিন্তু নোট 4 দিনের, অ্যাসাইনমেন্টও 4 দিনের, একটা অ্যাসাইনমেন্ট, 4 দিনের নোট একসঙ্গে, ঠিক আছে। মানে আমি 10-11 পাতার নোট একদিনে দিয়ে দেবো, ঠিক আছে। এইভাবে করতে হবে, কারণ রোজ রোজ এখন সবাই তোমাদেরকে ডেকে এখন কতদিন চলবে? অলরেডি 45-46টা ক্লাস হয়ে গেছে, তাই না? তাহলে এরপরে তোমাদের রোজ 4 দিন করে তোমাদের বিরক্ত লাগবে, তাই না? সপ্তাহে একদিন ঠিক আছে, তাই না? তো আপাতত 2 দিন করে চলুক, ঠিক আছে। তারপরে যদি একটু টাইম থাকে তাহলে কিছু অ্যাডভান্স প্রবলেম করাবো বা কিছু অ্যাডভান্স কিছু পড়াবো, ফিল্টার ডিজাইনের যে আরো পড়াবো। তবে এখন যে আয়ার টপিক পড়াবো সেটা খুব অ্যাডভান্স টপিক। অ্যাডভান্স টপিক মানে দিস ইজ ভ্যালিড স্টিল টুডে, Okay, so যাই হোক একটু difficult IR filter design, একটু difficult, but still you can understand lot of steps are there, but not an issue. I'll make it simple. Okay, now IR filter design. IR filter design. One more thing I forgot to mention. I have to take one or few lab classes that I will tell you before 1 or 2 days that I will take one lab class. That will be in between. Okay, that I will tell you later. I am actually preparing the documents. Once I prepare the document, I will give you. Okay, now IR filter design. First of all, why to design IR filter? What was the problem in FIR filter that I have to understand? So FIR filter, what we have designed. So first IR filter design, first we will understand why we need IR filter. That makes a sense. See, FIR filter, what we did, we have computed HM. So IR filter, any filter is a digital system. What we are trying to design is a digital system. Designing filter means you are designing a digital system, which is a filter, and a digital system means it has to has an impulse response HM and transfer function HJ. When I'm talking about system means I'm talking about two things. In time domain, I'm talking about impulse response, and in frequency domain, I'm talking about transfer function. That's all. Now the question is what we have done in FIR filter. FIR filter, we have computed HN on the basis of what? On the basis of number of samples given, that we have to design with 10 sample, 20 sample, 15 sample, 7 sample, 8 sample, 9 sample, like that. On the basis of that, we have designed and computed HN. And any filter is a system. So depending on the value of HN, we have categorized filter into low pass filter, high pass filter, band pass filter, and band stop filter. That is depending on the value of HN. HN having different kind of value for low pass filter, high pass filter, and band pass filter. They are having different kind of value. So essentially, what we have done, we have computed HN, then we have computed the frequency response H of e power j omega. Then we have computed transfer function of the system to realize the system. That means if we want to make the hardware, then what are the things we have to we required? That says in the diagram, that is called realization diagram, what we have done in the context of FIR filter. Now, what was the problem in that? First of all, the problem of FIR filter is that we have designed a FIR filter. What are the specifications? The specifications are low pass filter, cutoff frequency, high pass filter, cutoff frequency, band pass filter, band stop filter to cutoff frequency. This was the specification. Another specification that was given, that number of samples we required, and also we have used, that is not the specification, that may be specified, may not be specified, but what thing we have used, that is called symmetric foundation of the filter. So essentially, we have designed those filters on the basis of this specification. However, these specifications are not sufficient in the context of practical filter design, always. In the context of practical filter design, always. Now I will elaborate this statement. What I said, that in practical filter design, high quality filter design, these specifications are not good enough. That I will elaborate now, step by step. Now, first thing, that let me understand what was the advantages of this design. This design having finite number of points, and this design have linear phase in case of FIR filter, that we have understood. So filter design means filter design computation of this we have done in FIR filter. And specification digital cutoff frequency, that I have said, this is a thing. Now, this design specification is not good enough for high quality filter. That means number of samples only, cutoff frequency only, and frequency response hardware. This is not sufficient for high quality filter. Why high quality filter? For high quality filter, this is ideal response, this is all right. For high quality filter, this is not the only specification. Like for industrial design, this is not the only specification. You have to specify what is the passband edge frequency. That means when passband Gradually, I said the practical filter is like this for low pass filter, and this is your ideal filter. I'm talking about 0 to pi and 0 to omega, omega positive. Now, the practical specification may be what is the passband edge cutoff frequency, passband edge frequency, and what will be the permissible limit of variation in the passband. That means initially high, then it is gradually reducing. Ideally, it has to be constant. Ideally, it cannot design with hardware. Therefore, we have certain this kind of graph we have seen in practical filter design, but we didn't say the specification what is the passband edge frequency and what is the tolerable limit within the passband amplitude variation. Similarly, when this is passband edge frequency, that means passband almost complete and stop band starting, and in between there is a transition band. Transition band means passband edge cutoff frequency and start of the stop band, that called omega p to omega s. This region is your transition band, and omega s is the stop band edge frequency. And also in stop band you have to have ideally 0, but what would be the permissible limit of amplitude within the stop band, that may be specified. So in practical filter specification, practical design, high quality filter design, you need a specification within passband, you need a specification of passband edge frequency, you require to acquire the specification of stop band edge frequency, and what will be the variation of amplitude within the stop band, what will be the variation of amplitude within the passband, that also will be specified. But in a FIR filter design, those things are not incorporated. So this is a simplistic filter design, but there are applications where we do not require such high quality filter design. If I design a filter and we can manage the application, that is enough, because this is simple in hardware in a FIR filter, and that was simple in design, very simple in design. Therefore, this was adopted in those applications where the specification like passband edge, stop band edge, and variation on the passband stop band, these are not the criteria. In those areas, your FIR filter is applicable. Now, a question may arise. A question may arise. Hello. Hey, current galo naki? Current chale galo naki? এসি বন্ধ হয়েছে, তার মানে কারেন্ট নেই। হ্যালো, শুনতে পাচ্ছ?
Yes, sir.
হ্যাঁ স্যার।
বন্ধ হয়েছিল নাকি?
হ্যাঁ, sir.
না ঠিক
হ্যাঁ
স্ক্রিনটা দেখা যাচ্ছে? স্ক্রিনটা?
হ্যাঁ
Therefore, the practical filter design, what I was telling about, I don't know কোথায় কেটেছিল, কোন জায়গাটা কেটেছিল, কতদূর বলেছিলাম? হ্যালো হ্যালো, শুনতে পাচ্ছ?
হ্যাঁ স্যার।
Okay, so the when a high quality filter design is required, in such a case, specification of pass bandage, stop bandage, frequency, tolerable limit within the pass band, stop band, they are required. So this kind of filter design, when a high quality filter design is required, where design specifications are very tight specification, such kind of application FIR filter cannot be employed. Then we have to use IR filter. We have to use IR filter. So those areas when a tight specification of the filter is required, then we require IR filter. Now, one important thing in this stage, FIR filter, what is the major advantage is, any system you design, the system has to be stable, means stability criteria has to be followed. In FIR filter, two major advantages at this stage, if not more. One is linear phase, Linear phase, I have said, it is important because it helps to reduce phase distortion. If in linear phase, no phase distortion is one of the important thing. Second thing is a FIR filter is by default stable. By default stable means what? By default stable means if you have 7 sample, if you talk of time domain stability, then some of this coefficient that has to has a finite value. That has to has a finite value. So if I have 7 coefficient, if I add them together, definitely that will be a finite quantity. So this is stability is guaranteed in case of FIR filter. One advantage. Second advantage is linear phase to avoid phase distortion. These two things guaranteed. At the same time, third advantage is it's a very simple design, simple hardware. It is the third thing. So that FIR filter was very famous till today. But the thing is that the tight specification means it cannot incorporate tight specifications. So if also sometimes a application, if I have low cost filter, like I have to manage with a FIR filter, and we have certain tight specification that passband, stopband you have to control, then there is one approach in FIR filter that is followed, that we may change the order of the filter, we may change the number of points, one thing, then number of order of the filter. At the same time, we can use different kind of window. These are the two approach
Sir,
by which
order of the filter কি বললেন? Order of the filter বলতে কি বোঝাচ্ছে?
Order of the filter বলতে বুঝছি আমি number of samples. Number of sample decides the power of the Z power. Suppose if I n equal to 7, then my order of the Z transform is Z power 6. So that means maximum value is 6. I can change this n may be 10, n may be 15, n may be 12. You can go for higher value of n. In other words, if I go for higher value of the sample. So in a polynomial, if I say highest power is the order of a polynomial. So if I take hz is a polynomial of z, then the highest power is for n equal to 7, highest power is 6. Order of the polynomial hz is 6. So this depends on number of samples. Now suppose I have designed n equal to 7 and I have used certain symmetry condition, maybe h of n minus 1 minus n equal to hn. This is a symmetry condition I have used. And I have used some cutoff frequency, say 0.2 pi or 0.4 pi. But that cutoff frequency you have to maintain. Now I want to control the pass band and stop band and transition band. What are the options in front of me? The options in front of me, I can change the order of the filter. N is 7, suppose say I can change the order to maybe 10, and I may see what is the response. And I can do one more thing. I can change rectangular window. I may take a Hamming window, Hanning window, some other windows I can take. Then I can manipulate the whole thing. But such manipulation cannot give you a guaranteed solution. Guaranteed solution. So if I require a filter with very tight specification of pass band tolerance, and stop band tolerance, then if we do this in manipulating the technique, trial and error, that is not a good solution. Not a good solution. Anyway, again, the important point is, even though it is not a good solution and it is a trial error technique, but that trial error is done by the computer. Suppose if I design a FIR filter using computer for n equal to 7, then in MATLAB, if I make the n variable as an input, then I can change the input, I can change the program for window, then I can see different kind of combinations. Then I may reach to the specification which is near optimal, but we cannot design with a guaranteed response. This was the drawback in FIR filter design. But I am not saying that FIR filter design is not important. It is important in the sense such application when I have to design a very low cost filter, at the same time that will somehow meet the specification, very rough specification, with two basic advantage. One is linear phase and stability. FIR filter still could be used, right? FIR filter specification sometimes could be achieved, even high quality filter, by changing this manipulation. But a technique which involves trial and error and manipulation, it's not the good technique in engineering. All right. Therefore, we require a better filter That leads to the concept of IR filter. Okay. So I hope you have understood what is the necessity of IR filter. Is it all right? Is it all right? Necessity of IR filter.
Yes, sir.
Very good. Now, so design specification for IR filter means pass band, stop band, and this edge, everything you have to consider in case of IR filters. Okay. So what we have covered up to this design with appropriate specification. What I written when strict specification, I said strict specification is given, then for FIR filter that can be changed by changing the value of n and window, but cannot be guaranteed. Okay. IR filter ensures filter design with appropriate specification. Okay. Now, what are the steps in IR filter design? Then first step is digital design specification mapped into analog specification. Okay. Then IIR filter, the name suggests this is infinite impulse response. Infinite impulse response. So if the impulse response is infinite, definitely there are two problems with that. One is, suppose I am finding HZ with infinite number of coefficients. Infinite number of coefficients. Then first of all, I have to find the summation of the series. Summation of the series. Infinite series, I have to summation of the series. Second thing, stability also I have to check, because if I have infinite response, it may be stable, it may not be stable. That I have to check. Because whether the specifications are strict or very tight specification, you have to design filter, but basic condition has to be maintained. Basic condition has to be maintained. Means what? Means stability of the system should be there, and you should be in a position to find a compact form. Unless you find a compact form like HZ equal to some compact form, you cannot realize that filter. And we have already covered one topic, that IR realization, direct from one, direct from two. So IR could be realized, it could be practically designed, provided it is a stable system. So when at the time I am saying that it is a IR filter, infinite impulse response, two things I have to ensure: convergence of the series, first criteria. I have to find a compact form. Unless you find a compact form, I cannot realize. If I cannot realize, I cannot prepare hardware. So hardware has to prepare. So a compact form realization is required, first thing. Second thing that I require, that system has to be stable. This is the basic criteria. Unless it is a stable system, we cannot work with the system, right? So two things. And stability, what I understand, if the input is bounded, output has to be bounded. That depends on impulse response. Impulse response has to satisfy. Magnitude of that will be less than infinity. In other words, that if I adapt the filter coefficients, that value has to be a finite. That relates to the stability in time domain. Therefore, at the moment I am saying IR filter, infinite impulse response, so two problems immediately comes into the picture. One is convergence of the series. In order to achieve a compact form, to realize the filter using direct form, indirect form, etc., so that I can prepare a hardware. This is one problem. And second problem is stability of the system, that IR system did not necessarily be stable always, which was the advantage of a FIR filter. It was by default stable, but IR filter is not stable by default. So stability has to be checked and ensured. These are the two things that you have to ensure. Okay. Now, I cannot directly find the sum or convergence using HZ. HZ. Suppose if I have HZ equal to 1 plus causal filter means n equal to 0 starting point. So if it is n equal to 0, z to the power 0, 1, then H1 next term z power minus 1, h2 z power minus 2, h3 z power minus 3, like that. Now, such series, when it goes to infinite, how do you find the summation? How do you find the summation? Are you following the problem? Hello?
Yes, sir.
For a problem, বুঝতে পারছো? Suppose you are having hn having, try to follow this statement. Suppose hn having infinite number of values, and I have to find an expression for hz, compact form. So what I am writing, hz equal to 1 plus h1 into z power minus 1, h2 into z power minus 2, h3 into z power minus 3, plus infinite number of terms. Now, how do you find the summation? Since hz is having the power of z, so to find a compact form, somehow I have to get a GP series or geometric progression series. Unless I get a GP series, I cannot find the summation. Okay. Now, suppose h1 value is 0.01, h2 value is 0.05, h3 value 0.07, like that. Then my expression will be 1 plus 0.1 into z power minus 1, 0.5 into z power minus 2, 0.9 into z power minus 3. Then you cannot put it in a GP series, right? So if you cannot put in a GP series, you cannot find the sum. Is not it? If you
Yes.
cannot find a GP series, then how could you find the sum for infinite value? It is not possible. Therefore, we cannot design digital filter. We cannot design digital filter directly in digital domain, because I cannot find a compact expression using hz, because I cannot find a GP series. Because hz essentially I have to solve using GP series in order to get a compact form. Now, if the terms of this series is such that they are having arbitrary coefficients, h1 could be calculated 0.1, h2 could be 0.5, h7 could be 0.7, h4 equal to say 0.5. There is no pattern. In such a situation, I cannot find the sum of the GP series. And if I cannot find the sum of the GP series, then I cannot find a compact expression for hz, then I cannot realize. This is the problem, first problem in this. And second criteria is stability criteria. I will discuss later on. So first of all, this is the problem. Therefore, digital IR filter cannot be designed directly because of infinite nature, and also the coefficient may be such that you cannot put it in a GP series in general. Therefore, the digital filter with digital specification cannot be designed directly in digital domain. Is it all right? Is it all right?
Yes, sir.
So therefore, I have to search for an alternative technique. This alternative technique is, first step is digital design specification. Digital design specification, which will be given, that will be mapped into analog specification. So first I have to map this digital specification into analog specification. This is the first thing. Second thing, analog filter I have to design with that specification. I repeat, first I have to convert the digital, I have to design digital IR filter. The target is to design digital IR filter. Cannot be designed directly. I have understood why it is so. Once I understood, then what is the alternative approach? The alternative approach is digital filter specification. I have to convert into or mapped into analog filter specification. Then I have to design analog filter. Once I design analog filter, means it is a time domain t instead of n. Then if it is t, then corresponding transform will be hs instead of hz. So once I design analog filter with the specification, then I will obtain hs. So once I obtain hs, then I will convert this hs to hz. Hz is obtained from hs using h to z mapping / transformation. So there are two mappings. One is, first I have to convert the digital specifications into analog specifications. Then I have to design the filter in analog domain, and I have to obtain HS. Once I obtain HS, then I have to convert HS into HZ. Then I will get a direct form in a compact form of HZ. That completes the filter design. And once I get HZ, if I put Z equal to e power j omega, this will give you the frequency response. Because you already know that Z equal to R into to the power j omega in general, if R equal to 1, it becomes discrete time Fourier transformation. So from HS, I have to obtain HZ, and Z equal to, instead of R into e power j omega, if I put e power j omega, it will give you the DTFT equation. Then I can obtain the filter response in digital domain. So this is the steps by which we design IR filter. I repeat 3 steps again, that convert the digital specifications like digital passband edge frequency, digital cutoff frequency, digital stop band edge frequency, and tolerance within the passband of digital domain, tolerance within the passband of stop band of digital domain. That specifications I have to convert into analog domain. Analog domain. Once I got the specification in analog domain, then I have to design filter in the analog domain. And in analog domain, time is t, corresponding transform is hs. So after designing the filter in analog domain, I will get hs. Once I get hs, that hs I have to convert into digital domain, s to z transformation. Then I will get h of z. Once I get hz, my filter design is complete. Now I have to find the frequency response. I have to substitute z equal to e power j omega. I will get the frequency response or DTFT. So these are the steps of designing IR filter. Is it all right? Is it all right? Or any doubt if you have, you can ask at this stage. Any doubt if you have, you can ask. So far.
S to Z domain transform কিভাবে?
পরবর্তীতে পড়বো আমরা। We'll learn this, how to transform S to Z, how to convert analog to digital frequency. These things we will learn. This is the course actually in IR filter design. Basically, I have to, if I ask you to design a low pass IR filter, means I have to get the low pass response. I have to get the response, high pass response corresponding to filter. How these things could be done, that we will learn in this filter design course, IR filter design course that we will learn. Okay. So what I have explained so far, 2 things. One is why IIR, what are the difficulties in IR filter design, and what are the possible solutions that could be applied to design of IR digital filter. In these 3 criteria, if you have any doubt, you can ask. Do you have any doubt? Do you have any doubt? বলো।
স্যার ডিফিকাল্টিজ এর ওখানটা আপনি আরেকবার বলুন।
The difficulties, বলছি। Difficulties in IR filter design, there are 2 difficulties. Once I say IIR, 2 difficulties. One is whether it is stable or unstable. Because if you have infinite number of samples, infinite number of non-zero value of the filter coefficient, whether it is stable or non-stable, this is a question mark. First difficulty. Stability is the one difficulty, and second difficulty is if I write hz equal to what? h0 plus h1 into z power minus 1, h2 into z power minus 2, h3 into z power minus 3, up to h of infinity z power minus infinity. My question is that, then suppose if I want to find a compact expression of hz, what I have to do? I have to apply some GP series or GP formulation so that I can get the compact form. Now h1 is 0.1, h2 may be 0.79, h3 may be 0.31, h4 may be 0.41. If such is the value of h1, h2, h3, h4, etc., in such a case, how could you find a GP expression? Right? Because you cannot solve without GP series, because z power 1 minus 1, z power minus 2, z power minus 3, inherent nature is a GP. But the coefficients are such, I cannot put it into a GP series, because to find a sum using a GP series, what I required a constant common ratio R. Unless I get a constant common ratio R, I cannot solve a GP series. The R has to be the common ratio, is not it? So this is the one difficulty of getting HZ. If I don't get HZ, what is the problem? I cannot realize. If I cannot realize, I cannot understand what is the requirement of hardware. Right. Once I find HZ, then I understand that many number of delay required, that many number of multiplier required, that many number of address required. I can get the realization. They get it from realization diagram. Unless I get just diagram, I cannot realize. So for realizing, I required a compact expression. Right, a compact expression, so that I can realize. Right. Agreed. This is one difficulty. And stability is the one criteria. Unless it is a stable system, we cannot work with anything. This is a basic criteria, is not it? For example, if you want to run, suppose if you want to learn some advanced mathematics, first thing you should know the basic thing. If you cannot know how to, what is the basic thing that cannot alter? Suppose if you know something advanced, that means the basic things if we go back into, that should remain same. Right, mathematics has developed a lot, but still, if I ask you what is the definition of 1 plus 1, 2, if that is altered, then this is wrong. That you have to maintain always. So basic things you cannot alter. If it is a system, the basic thing is it has to be a stable system. Unless you cannot work with it, maybe IIR, maybe strict specification, lot of things you can do, but still, basic thing it has to satisfy. It has to be a stable system, and it could be realized in hardware. Suppose you develop anything in theory, but you cannot realize in hardware. What is the use? No use as such. Therefore, to realize the hardware, we require the compact form. These two things cannot be directly done in the digital domain. And that difficulty raised into the alternative solution that map the digital specification into analog specification, design filter in analog domain, and once to analog domain, if I talk of, you have to obtain H of S, that is S domain. Then I have to convert S to Z using the mapping. That you will learn what are the different mapping techniques that you have to learn. So, any doubt if you have? I hope everything is all right now.
Yes.
স্যার
Any doubt?
স্যার বলছিলাম যে মানে এফআইআর তো করাটা অনেক সোজা যেহেতু ফাইনাইট ইম্পালস রেসপন্স
Yes,
আছে
yes, yes, yes.
স্যার তাহলে আমরা আইআইআরটা কেন করছি
কারণ হচ্ছে কি বললাম যে we cannot design with strict specification. Then when I am designing a FIR filter, what are the specification? Specification is number of samples. Specification is the symmetry condition maybe you talk of. Specification is the cutoff frequency. But I don't have the option of incorporating the passband edge frequency, stop band edge frequency. What is the tolerable limit within the passband? What is the tolerable limit of amplitude within the stop band? This is not specified. So such specifications are required for high quality filters. Industry level filter, we require such high quality specification that cannot be achieved in a FIR filter with guarantee. Yes, this is the filter, this is the specification. We cannot say this in that case. So that was the difficulty. Agreed? That specification we cannot incorporate in FIR design. Understood?
Yes, sir. Got. Yes, sir.
Very good. So, with this understanding that we need to design IR filter, what is the need of this and what essentially this is, we will now write few lines. Let us read this. In design of IR digital filter, the specification of IR digital filter, IR digital filter, IR digital filter specification you have to achieve. So first, IR digital filter is transformed into the specification of analog filter, and analog filter transfer function HS is designed to satisfy the specification. Then the analog filter is transformed into a digital filter with transformation HZ. This is the steps in brief. Okay. Now, now I have only 1 minute, so I think today I don't want to continue. So today I have covered up to 2 pages. Third page I have just started. So next class maybe in Saturday. So you read. I will tell today. I will give you note of 10 to 11 page. So notes of yesterday, today, tomorrow, and Saturday. This 4 days note. This is right. So you try to read this of your own. I will start explanation from page 3. Right. Next class onwards, I will discuss the page 3. What are the stability criteria in Z domain? What are the corresponding transformation in S domain? Then what are the different kind of mapping techniques? I have given one mapping techniques here I have discussed. So you try to read this. I will discuss these things, rest of the things in Saturday from page 3. Okay, I am having less than 1 minute, so I would like to stop today, and next we will discuss. So okay, and today also I am not giving any quiz. I will give you quiz in Saturday. So I will send you today notes. All right. So I hope you have understood
Okay,
so far what we have discussed, and rest of the things we will discuss in Saturday. Okay. So I would like to conclude. How many of you attended? 11.
11.
11.
Yes, sir.
Anushka,
Yes,
Anu,
sir.
Anu, Kya, Anushka, Nupur, Ananya, Aritya, Akash, Rajni, Sanjana, Aniket. All right.
Ami sir.
Aniket.
Amit.
Oh, Amit. So no, Amit is okay. No, no. It's okay. We'd like to stop here, so we will again discuss in Saturday. Okay. Thank you.
Yes sir. Thank you sir.
Okay.
Thank you, sir.
Thank you, sir.